Okay, so this is our project, and what we decided to build, I like to call it a electromagnetic raceway generator. So what it is essentially it's a generator, just like the generator that you put in a wind or water turbine, except that we've simplified the design to allow it to create energy as long as this moves. It can create energy day and night, day in, day out, as long as we want it to. So essentially what it is a hula hoop. We cut a hula hoop to create a semicircle. And using the semicircle, we attached a bunch of copper magnet wire we got at Radio Shack. We wrapped it hundreds and hundreds and hundreds of times to create a coil, which is essentially what they use to create electromagnets. And inside the hula hoop is a small magnet, a spherical magnet, that rolls around when this moves. So every time I move this, that magnetic ball goes in between this coil. And when the magnetic field goes through the coil, it excites the electrons, pulls the electrons through, creating a current. The current goes through the coil, through the leads, and into a capacitor. But right now we actually have it hooked up to a multimeter, which allows us to read how much electricity this actually produces. It doesn't produce a lot of electricity right now because it only has one coil. If we add multiple coils, that means there's more electrons for that magnetic field to go through, to pull, to create even more current. It's one of the simplest generators you can make. As you can see, we made this for maybe $5 to $10, so it's a very cheap and very reliable. As long as this moves, it creates electricity. No matter what, this moves, it creates electricity. We tried lots and lots of different techniques to get this to move, and we decided on putting it on a string, because all the other ones, all the other techniques, they didn't produce enough movement for this to create sufficient electricity to light, say, an LED. So by putting it on a string, we can get enough movement with as little energy. See, I'm barely moving my hands, yet that ball's moving pretty fast. And on the multimeter, we're getting almost a volt of electricity sometimes. It spikes. So it's not creating a bunch of electricity, but it is a prototype, and we are about to see how much this can actually create. Okay, so we have the camera zoomed in on the multimeter, and we have the project, the generator. It's hooked up to the multimeter by these two cables. The red one and the black one, these connect to the multimeter, and then the two leads coming out of the generator connect to these two leads. So that's how it's connected, and we're going to see how much electricity the project can actually produce. Now, as I said before, it gains this electricity as this ball moves back and forth in the hula hoop. As it goes through the coil, it's pulling all the electrons through the coil, producing current, and it's going through the leads, and the multimeter is measuring how much electricity is being produced. Let's put it, actually we need to put it in AC current because the magnet produces AC, and we'll see how much electricity we can actually produce. Okay, so I'm rocking it back and forth. We're seeing some voltage. We're getting spikes at about half a volt so far. Let's see if we can get a little bit more. There we go. We've got this up to about 1.1, 1.2 volts. Just to put that in perspective, the lowest powered LED, that only runs off of 1.8, so we can't even power an LED yet. But all of that can change once we add a second coil, to just add a few different changes to the design. Okay, that's enough. We'll see how much. So our highest spike was around 0.1 away from 1 volt, so about 0.9 volts. So all in all, this is a very, very reliable, it's very consistent, and it's one of the cheapest designs out there. It doesn't produce a lot of power yet, but we're still working on that. and hopefully we'll go pretty far in the Toshiba Explorer Vision competition.